Right, hello. Good afternoon, everybody. Welcome to this class. It's a pleasure to host it. Small class, but we're very happy that you are here. Today we have the possibility to talk about the topic or the question AI first or AI washed. My name is Christoph Heberlin. This is Baptiste Busch. We will introduce ourselves in a minute. Now, when I think about the conversations that I had this morning, I believe everybody is a bit tired of AI here and AI there, and nevertheless, it's the topic that we are talking about. In my job as a investment manager at Zürcher Kantonalbank, I see lots of pitch decks, and every one of them claims to be AI-powered in some way or another. I've actually seen the label AI so many times that it doesn't really mean much to me anymore. I think we need to go a step or a level deeper and ask the question, how can a company differentiate itself when everybody has access to high-quality intelligence? This is the topic that we are unpacking today, or that we want to discuss with you today. We try to make it as realistic as possible, and that's why it's not only me as talking from an investor perspective, but we have Baptiste Busch with us. He's building AI in robotics, and I believe this is one of the most challenging and demanding environments there are at the moment. Mm-hmm. Baptiste, may I ask you to introduce yourself?
Yeah, absolutely. Nice to see you here today. So my name is Baptiste Busch. I'm co-founder and CEO of ICA. We've been building physical AI before physical AI was a hype. We started in 2019 with a concept of control for robots, including AI, but not necessarily being AI first, as people like to claim it now. And I'm happy to be here to talk to you about those differences, what that means, and where the industry is going, at least in robotics.
Thank you, Baptiste. My name is Christoph Heberlin. As said, I am representing Zürcher Kantonalbank and its startup finance department. My background is in finance, so it is good to have a technical expert on my side. Now, for those of you who don't know, and maybe for founders who don't know ZGB and its venture activity, here a couple facts and figures. The bank decided 20 years ago. I mean, we work under this service mandate, right? And one point in this mandate is to foster innovation. The bank decided 20 years ago to do that through venture capital. In that time, we invested over $250 million Swiss francs only in the Swiss ecosystem. We are only Swiss-focused. We financed over 300 companies in that time, and at the moment we have a portfolio of over 180 active companies. Here on the left-hand side, you can also see a bit our, the stage and tickets that we invest. One important point is, everybody's always looking for a lead investor, right? That's a scarce thing these days. Unfortunately, we are not a lead investor, so we are co-investor. We always need a syndicate to invest in because we are sector agnostic. We are also from, my colleagues and my profile, we are more from the finance side, so we need someone who can really cover technical due diligence aspects. Good, then let's dive right into it. I'd like to start with a short reality check. I'd say that 2 or 3 years ago, building in AI meant largely building models. Now, today, this isn't the case anymore. As you all know, OpenAI, etc., they provide us with high intelligence through APIs very efficiently. In other words, I believe access to intelligence isn't a differentiator anymore, it becomes part of infrastructure. If something becomes part of infrastructure, competition, and also value creation moves somewhere else. So the question is, if the model or the access to intelligence isn't the bottleneck anymore. What then is the bottleneck? I'm sure you read about that and heard it. We say that the value creation moves from access to intelligence to, for example, data access or data quality, or the ability to integrate systems into real-world workflows and so on. I read and hear that a lot, but to be completely honest, sometimes I don't exactly know what it means. And this is why we are doing this class today. And Baptiste, I'd like you to bring you in here. From your perspective, building in robotics, where things are way less forgiving than in traditional software cases, where do you see value accruing today? Is it still the models, or did it already move somewhere else? And if yes, where?
Yeah, that's, I think, a very important point. Well, first, I'd like to bring a little bit of a nuance. I believe you're right that the model might not be the most important aspect anymore, but it's more the distribution. Yet, what we see is that the current model for robotics, they are not working. If you take Gemini or anything, right, it's like they are very good at doing text. It's good, but the robotics word is not textual. Okay, programming might be a little bit, but there is physics understanding, all of that. And so if you take scientifics from that word, one of them very prominent is a French ex-Meta lead scientist, Yann Lequin, who says like the current models will not solve robotics. Clearly not. The problem happens that for companies and the traditional crowds, right, and people that are not in this space, understanding what differentiates two models is almost impossible. And at the end, it's like, that's why if you are actually really building on those models, you might have a hard time explaining why you're so different from the others. Unless you're Yann Lequin and you can raise 500 million just as a seed round. I think
it was $1 billion, right, on
even
seed round. Yeah.
Yes. So that's a bit of a different story. But indeed, infrastructure in robotics is what matters most. It's about deployment, being able to deploy the models, training, because you need those data, and that's really, again, where it matters a lot. So, in my opinion, right now, for textual information, web, why ChatGPT and everything works is because the data was there. And we've been accessing those data, like Google has accessed those data for many, many, many years, even training us to give them data, and those captcha things, right? Like you're actually paying Google with your own time. So they got the data, and now they have the model, and that's done. This phase of robotics is not there yet. We are still in the data acquisition phase. We need massive amount of data, teleoperation data. We need people with camera coming from an African country, just cooking and recording what they are doing. We need what we call egocentric data, which is just a view, first-person view of what the people is doing, and labelize the data and understanding that, because this is the real world, and that data is not available on the internet. Mm-hmm. And that's really the bottleneck here. And then there is the problem of we want to deploy where? If we want to deploy in the home, that's very difficult. But if we want to deploy in the industry, that might actually be even more difficult because data is even scarcer. Of course, the factory that is building your iPhone doesn't want you to actually record data of what they are doing, because you might be able to know how many iPhones they are building in that factory and infer some things that they don't want you to know about. Mm-hmm. And accessing that industrial data is really the key aspect here. And that's why people like Google, Microsoft are positioning themselves as the platform for industrial, because what they want is industrial data.
Good, thank you. I think that's a very important point, because it shows that as I said, the bottleneck is not really the intelligence, but it is the integration into the real world. Yeah. I think we can build on that. To me, one of the most overused terms that I heard the last, 18 months is probably AI first. Every company claims it, but very few really define what it means. In my practice, what I see a lot is that you see a company that attaches an AI layer or an AI feature onto an existing product. And this is no criticism, right? I invested in companies 4 years ago, traditional software business. Nobody talked about AI, right? They built a company around that, they built processes, they built competencies. This was a company, and now if they need funds again and go into the fundraise, everybody says, I'm so sorry, but this is a traditional software. You get sold on the stock exchanges. Why should we invest here? Nevertheless, the investor sentiment goes into a direction where we want to see AI native models. And these AI native models, they function differently. A traditional software business is, and even if you put an AI layer on top, stays fundamentally deterministic, meaning we predefine what happens if we enter A, B, or C. There is no improvement or no learning. And a true AI first system has, in my opinion, and please correct me if I am not precise enough, but it is able to adapt, it is able to learn, and it is able to improve over time. Baptiste, can you give us your view on, or your definition and thoughts on what AI first means to you?
Yeah, I think that's quite right? So you said it, there is two ways. It's either you integrate AI in terms of your processes, so you have your product and your rule-based systems, and you have some kind of AI that manages that, and that's one way of doing it, or you let kind of the AI at the core and build around it. In my opinion, there are not that many companies actually doing that. I think a lot of the companies that claims AI first, it's AI washing here, if we use our terms that we said. Simply because right now, if you are truly a kind of AI first system, right? Like, agents that is able to build autonomously your software, it's a nightmare to maintain. You don't have any control out there. You don't know the output. You like reviewing. That doesn't work. That first. The economics is not defined yet, right? People now buy SaaS software. You buy your Netflix subscriptions. Companies also, they start to finally understand SaaS software. And what it means here is that you're moving from a subscription that is a fixed cost for a company to consumable unit, which is a token. Because if you really want to have AI in your systems, right now the only way of having that is not a subscription, is an API call and tokens that you burn. And that can grow infinite, right? Like we had to have an example, OpenAI hired one guy, founder of OpenClaw. He burns $1.3 million of compute cost equivalent in 1 month, all right? You want to have a system here in your industry that might burn $1.3 million in 1 month? Maybe not.
Yeah. Maybe here, do you think, you said it, in my opinion, I mean, what the difference is also is that with traditional software, you sold a tool.
Yeah.
You sold it to me and I could, a CRM, and I could do whatever I wanted. But an AI first system doesn't sell you a tool, it sells you a result.
Yes. Like companies like Lovable, right, for example. I would say those are probably actually OpenAI systems, Anthropic. Those are probably the only definitions of AI first, in my opinion, because they serve the AI as a tool for others to build upon. Again, my problem with that approach, and it serves you results, yes, But if you are using it as a developer, it's not a result that it serves you, it's a tool, right? And again, the problem of tokenomics, right, doesn't make sense. When you are a carpenter and you have a hammer, your hammer does not charge you every time you hit a nail, right? You would not buy that. But that's what Entrebrick is doing. Every time you do a request, it charges you. And so right now they put kind of subscriptions, you have a certain number of tokens left. Well, what if you need more, right? And you get hooked on that because you need more and more and more and more and more and more. The bills keep growing. And suddenly what, you can't work anymore because you don't have the money anymore. That's a completely paradigm change that is happening right now. That is difficult for the whole industry and even maybe the whole economics to absorb.
Yeah, absolutely. So I believe that distinction is important between AI as a necessity and AI as an enhancement. If we touch on the topic of AI washing, for me, this is not talking about whether a company is using AI or if it doesn't. It's more subtle. In many cases that I see, AI is present. It is present, and especially in these cases, the AI looks impressive. So you end up with a system that has some touch of AI, but if you look closer, and I believe from an investor's perspective, this is the crucial point, it is not where value gets created and where defensibility in the end stems from. What you have seen in the market or with your customers, what are patterns where something looks like a strong product but isn't yet?
Yeah, that's a common thread in robotics, in my opinion. But that has been far before even AI was the real thing here, where you had robots. Especially in robotics, there is a tendency to record impressive videos when they work. So you have, and it come back down even from Boston Dynamics having Atlas doing backflips. So Atlas robots, humanoid robots, the first one, they've been doing backflips for 15 years. I was watching them doing backflips when I was doing my PhD there. And it looks impressive, right? What they don't show you is how many motors they've burned, how many times it fails, and maybe what is the success rate on a backflip, right? And quite a lot of times, and that's, the problem is not necessarily that the tech looks impressive or not, is it robust enough for an actual deployment on a serious use case? At Amazon, for example, there is a saying that once in a million happens every day, right? So if your system fails, success rate of your system is 99%. That would cost millions to Amazon if they were deploying it at scale, because the 1% that is missing is too much. They want 99.99%. Otherwise, they're losing money. And right now, a lot of the technology that we see looks impressive, but nobody is talking about success rate. What does that mean? What are the failing mode? When does that fail? What happens when it fails? And that's here the key questions to actually ask.
And maybe also in that regard, I mean, especially in robotics, kind of the sales process is always that you're going into a demo first, and then you do a large-scale deployment. And is it also from a customer perspective difficult to really, to build a parallel between what worked in a demo and what worked and what will work?
Absolutely.
Is this a problem for you to sell it?
It's absolutely a problem, because either they overestimated the fact that it will not work, which is a possibility, or they completely underestimate it. But there is almost no middle ground here. I really liked, on Monday, I was at an event organized by NVIDIA, and the researcher from Disney Research, the head of Disney Research here in Zurich, mentioned something. The problem of errors is that you have the very easy errors to spot, and those ones you can solve them in the lab because they happen often, right? It's like the most common errors that you have, you solve them in the lab, so you solve them in that demo case, right? So you do maybe a POC, you solve those errors, they are quite easy to find, and you have probably a lot of them. That's not the problem. The problem is the long tail deployment. The one that starts happening when you have 1,000 hours, 2,000 hours, your system running, and something breaks. And it's so random that to replicate that, you don't know. And then it's like, that can happen anytime. And if you are running a factory, you need to be on call at any time because it might happen at 2 a.m. in the morning, even when the factory is absolutely needing to produce. And that is the huge problem. That's absolutely what will scale down any deployment of AI right now, and is still scaling down deployment of robotics quite a lot in those factories.
Good, thank you very much. I'd like to make it a bit more specific even. In robotics, we have systems that are highly rigid, hard to adapt, and other hurdles. So I'd like you to take the lead here and show us, in the use case of ICA, how you are dealing with that.
Yep, absolutely. Thanks a lot. So I'll start a little bit by giving some analogy to me. The problem that we're currently facing in robotics is a sensing, perception, and adaptation layer. And the fact that we deal with assets that were considered as investment until now. A company, like why you have autonomous car that drives, you're not going to buy a new autonomous car yourself, but maybe a taxi company might buy those autonomous cars because they see a business out of it and because it's interesting for them, right? But an industrial company that have been using robots for years, they treated those robots as investment, and they want to keep treating them like this and that it works for massive amount of years, because when you buy a robot, it's not only the robot, it's also all the integrations, everything that comes with it. I visited an aeronautics company. They have cells that are still working for 30 years. They bought them 30 years ago, multiple millions per cell, and they are still very much working. They're not going to replace them anytime soon just because you have a new AI model that comes in and looks fancy and you need to have something there. So when we deal with this type of problem, the fact that it needs to still work with old assets, mixing new assets, new robots, all of that complexify a lot the integration and the deployment. And that's one of the main reasons why people are talking about deploying physical AI on industrial settings. And what we see is humanoid robots, but not those actual arms doing anything meaningful. And the reason is, a lot of people think it's actually easier to say the robot is a problem. I'll build the humanoid robots because that will be much easier to deploy. It's not. The problem is not the humanoid robots, the problem is the infrastructure layer that you need to have to integrate those robots, integrate those machines into legacy systems that have been running for 30 years. And that are absolutely not AI ready by that matters. Now, we need to talk also a little bit about the fact that the AI very much right now is linked to one thing, which is the compute power, right? The GPU that you have, often by NVIDIA. Again, those industrials, most of the time, if you're an automotive company, you build a machine and you hope that it will keep producing for 15 years. If you buy it with a GPU right now, in 15 years, you're cooked. Your GPU is cooked. That's like, there is no way that survives. No way that survives 15 years of intentional usage. Like it survives maybe 2 years. In 2 years, it's outdated. So you do what? You replace it already. In 5 years, it's probably burnt, and you can't do anything with it anymore. So you replaced it already 3 times in the time the robots takes to be amortized and all of that. That's a huge problem for those companies right now. And that's why physical AI is hard for them to deploy. What we see at ICA also is the
big one.
Yeah, infrastructure layer again. How do we interconnect all of that? And that's what we build. As a result, what happens, in my opinion, is a lot of companies are trying to dissociate that. So you have companies up front that do AI training, which is, okay, I will focus just on the training part. I will get the data. I will train the model. And if someone wants to use those models, yeah, good luck and figure it out. And you see that quite a lot. I mean, NVIDIA is absolutely doing that. NVIDIA, when you look at what they are doing, they're getting the data, building a model, and deployment? No. Someone will do. And that someone is probably a company like ours or Accenture or all of those people that do some integration, and they will have to deal with the consequences of those models. So by definition, what I see is that the robotics deployment, like the actual physical space, is completely disconnected from the AI space. Nobody is doing that in continuous, almost. Very few companies. And so when you are at that space, right, you are an integrators, you want to use an AI model, what you do is, well, you download a model the way you find it, and you need to do some integration with it. You need to actually use it. You need to put it into your architecture, into your robots. Maybe you build some simulation to actually help you there because you want to have to test things before. And that simulation is not very accurate. It's not representative of your factory designs. A lot of problems happen when it comes to robotics. And then the hard part, the one that nobody wants to really talk about, is physical tweaking. Well, you need to actually fine-tune some stuff to just make it work and to maintain it. And so you see this problem for me is like we talk about physical AI in robotics industry, and you have AI on one side, physical on the other side. And somehow they need to meet in the middle and to do something together. We've been trying to deal with that, so mainly focusing on that last part, right? On doing, okay, how do we integrate model? How do we put the guardrails? How do we make them work for the use case of our industrial partners? And that's indeed a hard problem, and focusing on simplifying this. Because the interesting aspect is a lot of this physical tweaking can actually be automatically done by some AI models. You could like train some loops here, and that's what we've been doing that I'm going to show here. This is a very interesting use case. I don't know if that video can play or not. Maybe if I try? No, try not. Maybe it's not a video. No, it seems that it lost the video here. Okay, but that doesn't matter. Yeah. Sorry, maybe I. So, I don't know where it's gone. Okay. Yes. Good. So, in that video that I had put here, we've been doing what we call battery disassembly. The problem of battery disassembly is that you have a battery pack, and you don't know in which state it is. It has been used. It has been, maybe there are some defects somewhere, maybe it's matched. And batteries, by definition, is a problem because if you don't handle it correctly, it might crack, open, and fire, right? It's why now in your airport they tell you if you have a battery in your backpack, please be careful, and then all of that. They don't like it so much because it can take fire. And those are EV batteries. And so when you actually need to interact with it, you don't want to have the robot that apply too much force and then suddenly break the thing and the whole thing goes kaboom, right? Because those are assets. So training a system to actually do a task, an AI system here, the only way you have is actually to go in simulation. It's like you take a simulators, you modelize your whole system, and you learn from there how to do it. And that's what we've done. So we have a simulator. The interesting aspect of that simulator when you start with simulation is you can really duplicate so many different conditions, right? That you cannot do otherwise, because you cannot just, you will never encounter all of the states a battery could be in real life. But in simulations, using what we call randomization, you can kind of make some estimate that my battery is in this state, my battery is in this state, and if I make a lot of those simulations, then I can learn from there. And that's what we did. So we made a task where the robots learn how to go under a cable, lift it, and just cut it. And we learned that fully in simulations, then deploy it on the real hardware. And when we deploy it, so our model is first learned in simulation and then deployed. When we deploy it, we add the guardrails to be sure that the robot is not going to put too much pressure, just break down the battery. And that's a very interesting way of going from simulations to actual deployment. But the loop, I would say, which is, okay, now that I have a deployed robot, how do I kind of like bring that back into the simulator, right? Bring that back into the learning. That is still a challenge that not many people are actually talking about. How do you make sure that once you have something that works in production, you can improve your simulations, you can improve your AI models? And that's still part of research. We submitted a grant for that in order to cover exactly this aspect, to have kind of a closed loop system on simulation and robotics, trying to bridge physical and AI together. Yeah.
Super, thank you. Maybe it's quite a chunk of information.
Yes.
Is there any, I'd like to open for the first time if there are questions to Baptiste about what he just said. Yes, please.
Hi everyone. So my name is Sorozani. I'm all the way from South Africa. So actually, this is it is not a question, but I just need an advice. So I kind of invested on my friend's business. So he is using Lovable as his platform to actually create a point of sale systems for different businesses in my area. So we've just got a big client. So the system can work, as you said, it can work for a number of times, but then it breaks. So the system broke on actually the stock that was left the previous day. So it actually, so I think it was worth 1,000 units, but on the next day it was only 9 units. So it costed that company a lot. So we either had to refund them. So I don't know, like, what can be the advice? Because I was thinking to say, okay, let us close this business before we lose. But he tried to convince me that he will fix that error. He fixed it, but I still don't trust it.
Yeah.
Because it's not the first time that thing happening. So I'm not sure if maybe we should go back and get a software engineer to have a code not unlovable. I don't know, because the system is working, but unlovable.
Yeah.
And it breaks.
You can have that opinion afterwards, but that's a problem that I see really a lot often, right? And this morning we had the keynote from Julian, who was saying, hey, everyone can build an AI company now. I told you, like, go for it and just do it, right? And that's nice, but be sure to not be something critical. And that's a real issue that you're describing. The problem is we've had software engineers in the past, and their job was not building. Building has never been an issue. Like, building, everybody can build. But the jokes between software engineers, and it's true, by the way, with electricians, when you hire a new electrician and he comes back to your house, the first thing that he said is like, oh, the previous one, what a stupid job he did, right? Like, everyone complains. And then in software, the same. You take a code and you're like, oh, who wrote that stupid piece of code? Sometimes you realize it's you 10 years ago. But right, that's the first thing you do. And we all know that. The problem now is that because of this AI, it produces massive code that you have no freaking idea what's inside. Right? And how do you review that? Sometimes you don't. Simply period. And we all know that code is not a solved problem. It's evolving. There is mistake. For sure, the AI will make mistake. Why? Because also it has been trained on human code that contained mistake before. So of course it learned how to replicate those mistakes. Simply put, right? So saying software is solved and we don't need engineers, complete bullshit. It's like, of course you will need engineers to maintain those systems. And that will even be much harder than it is right now. So true, there have never been a better time now to start something, but to start something that is non-critical. If you actually want to build a critical piece of software that can impact, I don't know, production, yes, hire a bunch of engineers to fix things before, for sure.
Yeah, I mean, I totally agree. I believe that maybe from another angle, it's also that these times, somehow they lead us into a paradox situation, because at the same time, everything gets easier, while everything gets harder. You know, technology is more accessible than ever. You can build a product faster than 5 years ago. But at the same time, to build a defensible, long-term successful company is even more difficult than before, in my opinion. Why is that? I believe differentiation diminishes fast. Modes have to be defined completely new. I also believe that the competition situation changes a lot. Yeah. I heard this story. I mean, I probably, you know, Andreas Göldi. He's an investor from B2 Venture in St. Gallen. He talks a lot about AI and how the future will look like from an investor's perspective. And he brought up this example. They have 1 or 2 image generation companies in their portfolio. And they were in their niche and they were successful. And I don't know, 6 months ago or maybe a year ago, Google released Nano Banana. And Nano Banana just destroyed these niche companies in 1 second. You know, imagine Google has a strong tech. They can integrate into their systems or into their suite. They have billions existing customers. If you are a startup in that field, your competition slide changes dramatically, and not for the better. Yes, it makes it easier, but you have no or not enough control if you're not working in a critical sector to really, you know, build something that is defensible. And I mean, also in that regard, and I'm sorry, but to me, the VC perspective needs to change basically on all dimensions that you evaluate the company. I mean, also, you know, the typical software advantages of, you know, high margins, it was defensible, you had B2B customers and so on. You know, the customers changed slowly once they integrated your solution. This is not the case anymore. You need to understand the unit economics from zero again. I mean, in my, you know, naive thinking, I believe, now we have an AI agent system, so in my OPEX, the staff cost, the employee cost, tends to zero or is just way lower. But honestly, I don't even understand the costs that come by applying AI. You have some inference cost and other stuff. This is still everything not yet defined. And that's why I believe that kind of it's not only a change; these are shifts that will change. Now, from my perspective, investing quite profoundly.
Yeah. 100%.
So excellent presentation, very valuable insights actually from both sides of you. Talking about defensibility, and I'd actually like to ask you a question about, since you mentioned NVIDIA, Marcus Gross probably, Disney Research and robotics, right? How about physics simulated data, right? So synthetic data, no one talks about it. I actually have heard Zero talk about synthetic data. That kind of makes sense and it means something. How defensible are those nowadays? And where do you see them being applied to robotics / NVIDIA-like companies, right?
Yeah, that's an interesting aspect. So I think a lot of people are actually using it to train their model, because you cannot record everything, right? Like you cannot, it's just too much if you were to use real world data for some tasks. The problem is generating those meaningful synthetic data has been hard in the past, and it's still very hard right now. And especially when it comes to something which is contact forces. When you do, for example, humanoid robots, you want those humanoid robots to be able to pick something, right? And to be in contact. But generating those contact forces in simulation, it's crazy difficult. The physics of the world, even the best simulator right now, they are not able to modelize accurately the physics of the world when it comes to contact forces, to fluid dynamics, all of that. There are people working on that, but it's non-solved problems. And that's why quite often you rely on physical data, someone wearing a glove, tactile gloves, taking your stuff, and there is still probably some technical moat here in a sense. But if you start to go into I need to build my own physics simulator to actually do that, well, good luck. You have NVIDIA out there. They have an army of people building their own simulation tools. It's difficult.
So practically what you're saying is that the companies that might survive the mode, the defensibility when it comes to tech are the ones who have very niche data
Probably.
that they can use physics sim as well on top of that. So from a
Probably.
VC's perspective, probably the VCs, especially in Switzerland, should look more on such companies, right?
Well, my view is on that sort of companies, yes.
So, and do you call them deep tech companies in the end of the day anymore, or not?
Maybe,
Because
I think it's...
It's difficult.
Yeah, it's difficult, I would say, yes, but I'm also not a fan of labels. So, if you have something where we believe it is defensible in a niche that is not crowded, where we believe kind of this hyper competition is not, coming over, then I'm interested, yes.
But the problem that I see is not necessarily only the technology by itself, but also with the customer. Unless you're actually building the technology to sell it once to NVIDIA or to sell it once to someone, right? But it's a different play. And I don't think you can really play both at the same time. You need to be very specific, because if you're working in those synthetic data, for example, fields, okay, maybe you're going to sell to all the humanoid robots companies that might want something there. Be careful that someone might bring an open source model out of your things. And especially, I don't know, they might use Anthropic to look at your repo or whatever, to look at your tech and say, okay, replicate it, and they have suddenly an open source model available. It's a lot of things now that are happening that are completely changing and redefining technical modes, deep tech altogether.
Cool. I think if there are no more questions, then we are done. Baptiste, first of all, thank you very much for these insights. And thank you for your attention. We'll see.